Thank you, Jason. Appreciate that. So again, my name is Jeff Williams, and I've been doing application security for a little over 20 years. I got started really early in it, and I've been fortunate to work with hundreds of really large companies on their application security programs. I did tons of penetration testing and code review, got really involved with OWASP in the early days, wrote the OWASP Top 10 and WebGoat, and led a bunch of other projects that some of you may have seen. I am so excited to talk to you about security observability and instrumentation. I want you to forget a little bit about what you know about application security testing and protection of applications at runtime, even software composition analysis. We're going to talk about a technique for analyzing applications that deserves way more attention than it's getting. We're going to dive into instrumentation. I'm going to show you how to do it with an open source tool called Jot that I created, and enable you to make things that have been traditionally really complicated in AppSec really easy. So before we jump in, I want to thank you for being part of OWASP. You really can make a difference. Application security is in its very early days still, and I know I've been doing it for a long time, but we haven't made a ton of progress in the first 20 years of AppSec. We've got a long way to go, and so it's a great time to be an AppSec. There are massive advances in the way that we do AppSec out there, ready to discover, ready to commercialize, ready to bring to market, and ready to change the world so that your kids won't have to worry about the security of their applications when they're doing their online banking and going to healthcare and thinking about using their government and elections and power grid and all that. The future of the world is really riding on us. So we got to figure it out. So thank you for being part of OWASP. So let's jump into this talk. So I always like to start talk with a few facts. These are facts that come from directly measuring tens of thousands of applications at runtime and monitoring their behavior for vulnerabilities, for attacks, for library problems. And it's just always interesting to me to notice that, you know what, this hasn't really changed. These numbers were roughly the same when I started in AppSec back in the early 2000s. Almost all applications have at least one vulnerability. The average software project is introducing 3-4 vulnerabilities a month. The average app has 30 vulnerabilities and a number of problems in their open source code. And this is an interesting fact. I'll just throw this out there. We directly measure library usage at runtime. And if you look at the way an application actually runs, 20% of it is custom code. We can assume that runs. 6% of it is open source code that actually runs, and the other 74% is open source code that never gets invoked and doesn't really present much risk. So I just want you to understand that when you think about, you know, SBOMs and library security and all that, like put it in perspective, like most of the code is actually custom. So that's kind of on the vulnerability side. It's also pretty scary on the attack side. The average application's attacked over 13,000 times a month. There were no applications that didn't get attacked every single month. And interestingly, 99% of those attacks don't connect with their intended vulnerability. Now, you can't measure that with a WAF. A WAF only knows, hey, that looks like an attack at the front door. But we track these attacks all the way through the application. So we know if it connects, if it's a SQL injection attack, did it actually connect with a SQL query and modify the meaning of that query? That rarely happens. 1% of the time that happens. So it's important to understand, you know, what people are attacking and which vulnerabilities they're actually connecting to in a way that they can exploit. So look, if you're real vulnerable and you've got a lot of attacks going on, that creates a dangerous situation, and the world is messed up right now. I'd be willing to bet a lot of you bank online. I want you to ask yourself, what do you really know about the security of the app that you use when you either use your mobile phone or you log onto the website, like connecting to backend APIs? What do you know about the security of that? Do you know how it was built? What components are in it? Who tested it? Does it have vulnerabilities? Do they keep their libraries up to date? Are the developers trained? You probably don't know anything about it. And that's terrifying, and that's got to change. It's not exactly this talk, but I do think we're making progress in this space. The executive order that just came out and the implementing regulations from NIST are doing a good job of pushing industry along to disclose a lot of the information about these things. And I believe it's going to change the market. Okay, so a little background. What do we do about it? Well, I want to talk to you about instrumentation. And I'm going to start by showing this basketball. This is the Wilson 9450. It's an instrumented basketball. It's got sensors inside it, and it detects the speed of your dribble and the rotation of the ball, the arc of your shot, and a whole bunch of other things. It comes with an app that gives you a bunch of drills, and actually, it's pretty amazing. I used it for a little while. I've been playing basketball for 30 years. It actually helps. It told me that the arc of my shot was too flat, and I made a change, and it improved my game. It's really amazing. And the reason I spend time on this is because I want you to understand the way that instrumentation can change an entire industry. Look at something like, just this basketball. We can change the relationship between coaches and players. If we have a basketball and drills that we can give the players and let them coach themselves and train themselves, the coaches can take a more strategic role, overseeing, helping players out with areas where they need help instead of having to do the day-to-day work. Same thing in healthcare. Many of you may be wearing Fitbits or one of those rings that senses your blood pressure and so on. Very soon, your devices are going to know you're sick before you do. They're going to monitor you 24/7 instead of going to a doctor once every 3 to 5 years and getting a checkup. You're probably never going to be sick at the exact time you go to the doctor. So, really a big change here. And all it takes is some instrumentation, some sensors, and some big data analysis to pull it all together. We can change the economics of application security with instrumentation. So let's talk about how it really works. The good news is software instrumentation is easy. We've been doing this for 20 years. Typically, people instrument applications for a little extra logging. Maybe they do some performance monitoring. This is exactly the way that tools like New Relic and App Dynamics work to measure performance from within an application. What we're going to talk about today is instrumenting an application so that we can measure security from within the application itself. So here's how it works. Every application starts on disk. It's a file, like a jar file, or we're going to be talking about Java a lot today, but this applies to any language. The executable exists on disk. And typically what happens is that executable gets loaded into memory and then starts executing. It's an exact copy of what was on disk. But modern software platforms provide the ability to instrument that code as it loads. So in order to get this instrumentation, we don't have to change anything about how we build, test, or deploy the code. We can add the instrumentation at runtime as the application starts up. And you can do this in a dev environment when you're testing locally. You can do it in a QA environment. You can do it in a CI/CD environment. Anywhere the code runs, you can add this instrumentation to give yourself unprecedented visibility to what's going on inside the application. So as this code loads, the loader has the ability to delegate to a transformer, an agent that will watch that code and add the sensors into it just as though they were written in the source code. They're not, we're weaving it into the binary. But as far as this, the ending purple code up here, it looks exactly like the developer wrote this instrumentation into their source code. It's a sort of a different way of assembling an app. So this is really cool. Then we're going to we're going to run this instrumented app, and we're going to collect any kind of telemetry that we want to know about what's going on inside that application. And as you'll see, there's a ton of really cool security stuff that you can analyze. This is a super surgical technique. It allows you to put sensors exactly where you want inside the application. The performance of these sensors is insanely fast. It's almost impossible to measure. And I've tried. I've started, run the same program with the agent, without the agent, done millions of requests, and it's almost impossible to measure. So we're talking about microseconds of latency here. So here's how I think about this is, I spent a lot of years doing pen tests, and someone once told me pen testing is a little bit like trying to find a problem in the water heater by staring up the shower, because you're just kind of throwing requests in and seeing what comes back and trying to diagnose that to figure out what's going on inside the app. Really difficult. I mean, it's, being a great pen tester is super hard. But what if you had a friend living inside the application that could tell you whether you hit something or not? So you send in a test case, HTTP request, and the friend could say, oh yeah, that third parameter that you sent, the name parameter, that flowed through the application and ended up in a SQL query. Well, that helps a lot, right? Now you can know, like, hey, maybe that's a target for SQL injection, and you can focus your test. You don't even have to attack the application if you know what's going on inside the application, as we'll see. So the other huge advantage of using instrumentation is that you're measuring what I call runtime reality, the whole app as it's all assembled and put together. And if you think about how some of the other tools in our space work, they don't work that way. If you're using a static analysis tool, it's probably just analyzing the source code as it appears in a repo. Now, is that the whole app? No, it doesn't include a bunch of critical pieces. It doesn't include the open source libraries, although you might be able to get that from the manifest or something, but it certainly doesn't include the app server. It doesn't include the platform. Many libraries are resolved at runtime. So if you want to understand how the application behaves, you have to look at it all the way assembled. The repo might also have libraries and code in it that aren't part of the production environment. Things like test code and frameworks and things like that don't end up in the running application. So you can end up both over measuring stuff and under measuring stuff because you don't have the runtime reality. So when you use instrumentation, you're measuring exactly how the actual application behaves at runtime. And that's why it's so much more accurate than traditional forms of analysis. So look, we're going to dive into this and talk about how you can do your own instrumentation. And I want to make really clear, I'm not talking about Contrast here. Contrast is an application security platform. It's got a bunch of different products in it. We're not talking about it today. We do use instrumentation for a lot of things, but I want to talk to you about the technique of instrumentation here. And I'm going to use an open source tool that I created called JOT. This is the Java Observability Toolkit. And it will allow you to instrument your own applications for security and for anything else that you want to know about what's going on inside the application. I think the big hurdle to using instrumentation is that it's a little bit difficult to write the actual instrumentation piece. It's kind of writing a program that modifies another program is a little bit meta for a lot of people. So I created this JOT tool, which will allow you to create sensors, deploy them as part of your application without any coding. If you can make a YAML file, you can use JOT to instrument applications and discover some amazing things that we're going to go through together. You can find JOT here in GitHub. It's totally free and open source, and only takes a few seconds to get started with. So let's jump into it. So I want to start with some ridiculously simple examples, and then we're going to get a little more complicated. So instead of, I've got this all to demo for you, so you can have the slides. I'll upload them after this so anybody can see what I've done here. But I'm going to show you how to use instrumentation on this app called Ticketbook. It's a really simple Java EE application that's got a bunch of interesting vulnerabilities in it and some other capabilities, but it's a fairly typical Java EE application. And we're going to use instrumentation to discover some stuff about it. So the first step is to grab a copy of JOT, and you can download it directly from GitHub. Actually, let me show you the project homepage. This is the project homepage. It's just planetlevel/JOT. And there's a bunch of documentation here about how you can create your first JOT. A JOT is a sensor that you're going to add to your application, and it's just a YAML file. And you can download it from here. You can just click into the release and just grab the latest jar file. Here, I actually like to just get it with curl in whatever environment I'm in. So I've already got it here. So remove that and just download it with curl. So now we've got our Jot jar file. So to use Jot, what we're going to do is we're going to start this application and tell Java to use this instrumentation agent. So I'm going to use an environment variable to do that. And let's make that one up here. It's already set up. So I'm going to use this Java tool options environment variable. That tells Java, use this Java agent flag, which is a standard built-in piece. It's called the Java Instrumentation API. In .NET, you could use the Profiler API, and every language kind of has one of these. We're going to use the jar file that I just downloaded. And we're going to add this expression like, I'm going to add a Jot file to this, and we're just going to use this untrusted SQL one. Let me show you what that file looks like. So this is a Jot. And you can see here, every sensor has a name. This is called get unsafe queries. It's got a little description, so you know what it's doing. It lists some methods. These are the methods that we're going to instrument. And in these cases, these are unparameterized database queries that might be susceptible to SQL injection. They're not necessarily susceptible, but if you have a policy internally that says, hey, we should use prepared statements everywhere, which is a pretty good idea, then this is a very fast way to discover any place in your app that you're using unsafe queries. And this applies not only to the custom code, but to all the libraries and frameworks and everything else that you're using. You'll be able to see exactly where these unsafe methods are being invoked. And it's really easy. So as I mentioned before, I set the Java tool options. And then all I'm going to do is run this application. Oops, this is a Tomcat. So we're just going to run this the normal way. And what you'll see here is as Tomcat started loading classes, and you can see it picked up our agent. It loaded the sensors. You can put multiple sensors in a single file because you might want to measure more than one thing. And then here, you can see it instrumented a few classes, and then it just continues to start up normally. So it adds, a fraction of a second to start up. And then you just use the application the normal way. So I can just browse around. I'll put OWASP. You don't have to put any particular data in here. This is kind of the cool thing is I can test this application without having to hack it. I can just click around and I'll put OWASP. I'll put OWASP. And you'll see as I do this, we're getting traces from the application showing me the exact line of code, the method, and the full SQL query that went to the database unsafely. And if you look, the method name is actually query unsafe, which is a little bit suspect, but it doesn't matter. Like however this gets called, you can actually get the full stack trace here if you want. So this is a really powerful way of quickly finding stuff. Imagine you put in a new policy in your organization that says, hey, as a company, we're not using unparameterized queries anymore. Well, that would take years to go, find all that in all your code and root it out. If you set up Jot to just measure this in your various test environments, you could find all the ones that matter, gather a central log of everywhere in the world that you're using unsafe queries, and then you could actually just go replace them with parameterized queries. So again, this is the simplest possible thing you could do with Jot. But I just wanted to give you a sense of just how easy it is for you to get started with instrumentation and some of the advantages over tools like static and dynamic testing, which are really complex to use. Okay, so that's the untrusted SQL one. We're going to go on to something a little more advanced here. How about we want to know everywhere where encryption is happening in our application? Well, let's take a look. So I've got a Jot for that. I'm going to cat jots/ciphers .jot. And you can see here, I'll move this up so it's in the middle of the screen a little more. So you can see here, we've got a sensor that all it does is put a sensor into cipher.getInstance. And here's a couple of interesting things we're going to explore in the JOT language. You can define multiple captures. And this is a way to capture information out of the running application. And when I think about this, I'm kind of thinking about like an electronics project where you're putting probes into a chip and into a circuit, and you're measuring data directly from the running application. That's a little bit what we're doing here. We just put one of our sensors inside the get instance, and then this P0 is the first parameter to the method. Now, this capture syntax is actually a Spring expression, and it's really powerful. This method, the first parameter is a string. So this is going to return a string. And if I wanted to make this more complicated, I could chain methods off of this. I could say, P0 dot to uppercase, and then we'd always get an uppercase query. And you can actually chain methods to branch out from where your sensor actually hit, your probe actually hit in the code. Then the other piece of a JOT is reports. So we've got sensors and reports. In this case, we're just going to make a real simple list to just show me the ciphers. I'll show you what that looks like. So here we're just going to change the JOT to ciphers, run the application the normal way, just like we always do. There's really no downside to running these sensors in the background. Like I said, they're super high performance.
Hey, Jeff, this is Jason. I'm sorry to break in real quick. We're having a couple folks that are having an issue with the screen share. It might be good to stop and restart the screen share.
Okay, I'd be happy to.
Thanks, sir.
Let me give that a try. So did they mention what the issue was?
They weren't. A couple folks weren't seeing it.
Huh. Okay. Well, let me find my Zoom, and here we're going to stop that share. So how about now?
Yep, seems to have unfroze. And if anybody has any freezing issues, just let me know in the comments. But it looks like it's good to go this time. It's unfrozen, so I think we're good. Thank you, sir.
Okay, well, sorry about that, and hopefully we're back on track. Okay, so we were just about to go look for ciphers. So I started the application up with the ciphers JOT, and again, all I have to do is just browse through this application. I'm really just clicking on links here. I know there's some encryption in these access pages down here, so I'm just clicking through those pages. And you can see over here, JOT has assembled a really nice list of all the ciphers that are used in this application, the exact line of code where they're used, and the specific algorithm that's used. So we've got some password-based encryption, some single DES, AES, we got triple DES, some different cipher chaining here. So this is a really powerful thing to get this visibility into your application and all the libraries that you're using. You would be amazed at all the places where applications are using weak encryption, using weak hash algorithms. We're going to be stuck with MD5 forever because it's essentially invisible in most applications. There are slides. I apologize. I was going through some slides earlier. I will post them after the talk, so everyone can see what I was talking about a little earlier. Fortunately, the good news is the interesting stuff is in the demo. Anyway, so this is encryption. This is how you can make it observable. And I encourage you to learn a little bit about observability. It's the science of making systems that expose their internal behavior externally. It's really important for security to be observable. Otherwise, you have no way of understanding what's going on. And right now, security is really not observable. Applications are a black box. It's really tough to see security in an application. So that's what we're trying to change here. We're trying to move from a world where security is not visible to one where it is visible. And I think it's going to have massive repercussions. Okay. So that's the encryption piece. You can see here, there's a little note on the syntax for creating those captures. You can access the parameters, the object itself, and the return for the method that you're inserting your sensors into. So that actually is a really powerful way, as we'll see, of accessing data from within the running application, kind of whatever you want to go look at. So let's take a look at access control. So access control is really, it's one of my favorite areas of application security because it's so hard. I used to do a lot of testing for access control problems, and they're just tricky because every application does it differently. And you want to verify that the application has the right access checks in it, but they're hard to find and difficult to understand. So let's see what we can do with instrumentation. So this sensor is a little more complicated. You can see we're adding 3 different sensors here. First one tells us what route is currently being executed. So this is kind of like the request URI. And notice we're fetching it from the service method, the first parameter of which is the HTTP request. The second parameter is the HTTP response. So we're going to get the request, and then we're going to get the URI from the request. So now we know what route is happening here. The next thing we're going to do is we're going to get the currently logged in user, and we do the same trick. We're going to get the request and then get the remote username. If it's null, we're just going to say guest. And then that's the Elvis operator, by the way, for the nerds in the crowd. I like that. The last sensor here is going to find access control checks. And here what we're going to do is every time anybody calls isUser enroll, which is a standard Java EE access control mechanism, we're going to capture the first parameter, which is the name of the role that's being tested for. Then we're just going to arrange that into a couple of reports. We're going to show a test coverage matrix, and we're going to show an access control matrix. And boy, if you've ever done any testing on a web application, understanding what the access control matrix is and what it's supposed to be are really difficult. I've spent weeks testing a single application to try to figure out how it all works. We're going to do it in about 2 minutes. So I got to set the variable here, the environment variable, to access.jive. Then we're going to run the application the normal way. And then we're just going to start clicking on some links. So let's take a look at what's going on here. So I'm just clicking through a few pages, and you can see here, Jot is capturing each thing I click on, and I haven't logged in or anything, so I'm just a guest. And it's telling me, hey, I tested that page as guest. We can keep going. We can just click on a bunch of pages here, and you can see pretty quickly, it's a nice way to keep track of like what I've tested as each role. And these last few pages here will allow me to switch roles relatively easily, like without logging out and logging back in. So it's a nice kind of demo. So I'm just clicking through them once as guest. And you can see, so now we've accessed all these pages, and we discovered some access control checks inside these access pages. That's kind of cool. We said, hey, in page A, there's a check to see if you're logged in as role A. In page B, there's a check to see if you're in role B. Page C, role C. Page D, let's see, did we test it? Yes. We know we hit it, but there's no access control check on page D. Should it test to see if you're in role D? Probably. We don't know until we go talk to the team. But look, we've just made the access control matrix for this application observable. Anybody can look at this on this project and go like, well, that's crazy. No role A people should be accessing page E. And so very quickly you can find problems this way in the access control matrix. This is starting hopefully to reveal some of the power of instrumentation. Let's do a couple things here. Let's switch users. I'm going to switch to user A and click on a few of these pages. And you can see, oh, look, now we've got more test coverage. We now tested these pages as both guest and A. And you can imagine, going through a test and saying, I tested certain pages with certain users, but I haven't tested every page with every user. And here you can see, I may have a test coverage matrix that looks kind of like this, and you can see some gaps, right? I know that page C tests to see if I'm in role C right here, but I haven't even tested page C as user C yet. So I know I've got a gap in my test coverage. And again, this is really about making your testing observable, because you do this with a real pen tester and actually measure what they cover, and you're going to see some dramatic gaps. Same thing with a DAS tool. You're going to see massive gaps in what gets actually tested. And that's important because you want to make sure that you've tested everything. So I think this is really powerful. Everyone should run this on their application. You could quickly make your own jot here and add in your own custom access control method. Like if you've got an isAuthorized method or something, you could add that here. Instrument it, find out exactly where it's used, and build your own access control matrix. It's super easy. Okay, and by the way, access control just moved up to be the #1 thing in the OWASP top 10. It's really prevalent, and it's not very well tested. So you want to make your name as a hacker, this would be a great way to do it. Okay, let's do some other stuff with instrumentation. Let's look at generating diagrams. So Jot can do this for you. Jot can take a set of sensors, and here I put one on route, any calls to get parameter, unsafe queries, encryption, and expression language execution. And then I just run my application normally, and Jot will automatically create these flowcharts of everything that's interesting for security from within this application. So it's just a kind of a very quick way to cut through the noise and see what you're really interested in inside an application. And you can add whatever sensors you want. You want to see, calls to the back end. I think just before this, there was a talk about SSRF. SSRF is pretty hard to test for. But what if you had a way of quickly finding every place your application makes a back-end connection? Every time your app issues an outbound URL, you want to know about it. Well, Jot can do that really quickly. In this case, you can see, hey, here's a parameter that was just read, a call to get parameter, and the value was, the ticket was the name, and the value was 10,001. And then you can see right in like the next thing, you can see, hey, there's an unsafe query, and oh, look at that. The name of the ticket has value 1001. So you should probably be thinking about SQL injection. This is not a lock, by the way, but it's really pretty good evidence that there's not proper parameterization going on. There may be some kind of validation or something or escaping that's going on here. But you could put sensors on those things too. And if there's ever a path from a get parameter through to an unsafe query that doesn't go through some kind of escaper, well, guess what? You probably got a problem. Here's another example. This is expression language injection. This is kind of everywhere. I dare you to run this on an application written with Spring or struts. You're going to see expressions get evaluated all over the place. It's pretty hard to test for them because you got to test every single field and every single header on every form, on every page, and every URL parameter. But using instrumentation, you can make these things show up incredibly quickly. And then here's an example of a command injection. And this is just kind of interesting. You can see the route, get parameter. You can see here's runtime.exec. And then here's everything that happens inside runtime.exec. You can see it actually creates a whole bunch of ciphers for a SSL connection all under the hood inside your application. So again, this is like turning the lights on, seeing what your application actually does as opposed to just kind of guessing by looking at the source code. Now, here's an idea that I think its time has come. Many of you maybe have experience with running some tool and getting a big PDF report. It's got hundreds of pages, tons of vulnerabilities, lots of false positives in there. And that's how we're communicating to developers. Well, that's not how they want to be communicated with. We need to do a better job of communicating with developers the way that they expect to be communicated to. So using instrumentation, you can turn those kind of findings that you used to create in a report or maybe a Jira ticket or even some kind of notification. We can do even better than that. Why don't we communicate with developers right through test failures? That's really what they'd love to see. So here I've got an example of a jot that flags any use of process builder here, which is what's underneath runtime.exec in Java. So anytime you create a native process, you're going to start a process builder. And we're going to just tag this here so it only fires when you're inside a test case. That's what the scope is all about. And then anytime we see that, we're going to give a nice note to the developer to say, hey, to prevent command injection, it's our policy that we don't allow use of operating system commands from within web apps. Contact security for help. Now, all you have to do is run your test case. And this test case has nothing to do with security. There's, it's just a normal test case that they would have written to test their code, but it does call runtime.exec under the hood. And so they'll automatically fail that test case and get a notification telling them how to fix it. I wrote a whole article about this sort of developer-friendly security reporting, but we can do a lot better at enabling developers to make the right decisions. You can imagine using instrumentation to take most of your secure coding guideline and turning it into code, turning it into JOTs that then do this kind of thing to communicate with developers. This is the path towards a really solid pipeline. Oh, I love this one. Okay, so let's do this expression language injection example. So in this application, there's an expression. Oh, I stopped it. Let's start this application. I'm still using the old access JOT because we're gonna use the expression language JOT in just a second. But for now, let's just take a look at this in its uninstrumented exploitable state. So this application has an expression language problem. This field, whatever you type in, you see it come back as part of the web page. Now that in itself looks more like XSS than it does like EL injection. But if you enter an expression in this field, something like, I don't know, 5 + 5 or 6, you'll see that this expression got evaluated and returned the result into the web page. Now, any header, it was a header for struts. This is the underlying problem that caused struts. There have been a number of recent attacks. Atlassian just had a major flaw that was with this. And I'm going to show you how to detect this and fix it really easily. So, when hackers see this, and there's a bunch of different syntaxes for this expression, like you can put in, hash sign here and get this evaluated. There's a bunch of different ways. But when a hacker sees this, they start thinking like, oh, wait a minute, I'm running a little bit of code here. What if I put in like math.max 2,5 and sent that in? Ah, interesting. Look at that. I can call methods. Awesome. So now you're telling the server to run a method for you. That's like 3/4 of the way to a takeover. And if you choose your methods wisely, you could do something like this. You could do runtime.get runtime. Something like that, right? I'm going to copy this so we don't have to type it again later. So when I do this, and that's almost exactly what attackers did to Equifax and Atlassian and others. They send in an operating system command. They don't start a calculator. They actually start up a reverse shell, and they take over your server, and they can do anything that server could do. They can steal your code. They can access your database. They can do just about anything. So how do we deal with this with instrumentation? Well, guess what? Let's look at a JOT. So here's a JOT for expression language. We're doing the same thing with the routes. That's just to tell us what route we're on. This is the key piece. We're going to sandbox the expression language engine. So here, we're going to prevent harmful methods from being called during expression evaluation. So the first thing is we're going to set a scope on this sensor. So it only fires when you're inside expression evaluation. This is the EL API, and this is the when you actually call to evaluate an expression. And if you're in that scope, we're going to look for methods like process builder and creating sockets. You could add to this list. You could say, hey, don't create any files. Don't start server sockets. There's a bunch of different things that you could prevent here. But we've created a very simple sandbox around the expression language engine so that it can't be exploited. And this is the line that does all the work. When we see something that matches the sensor, we are going to throw an exception. So we're not going to allow this method, this value expression.getValue, we're not going to allow it to execute because we're going to throw an exception that prevents the attack. So let's run our application with this. So we're going to set this to the LI and run the application normally. And wait for that to start up. And let's go back to the expression language lesson. And let's, we can see that this works the same way. We haven't disrupted its ability to evaluate expressions, so we can still evaluate expressions. What we stopped was the ability to do harmful stuff. So when I put in this attack that we looked at, this is when Jot is going to intervene and prevent this request from successfully evaluating an expression. So actually, if you look down in the stack tracer, you can see really what goes on. Here's the value expression.getValue call that we put this sensor on. That's the scope. And then inside there, we called runtime.exec. That's the expression being evaluated. And that called process builder. And when we hit process builder, the sensor fired and says, whoa, we're not allowed to do process builder inside an expression language evaluation. Because why would you ever want to evaluate? Why would you ever want to start a native process inside an expression? Like it's just not it really only means that you're under attack. So this is powerful. If this little Jot, if Equifax had that, then they would have been safe. All they would have had to do is add that Jot to their applications. There's no performance penalty here. It's incredibly fast, and they would have been safe against expression language injection forever. Okay, so let's big picture this a little bit. The first thing that we did was we used instrumentation to detect vulnerabilities, right? We found some SQL vulnerabilities, we found some encryption vulnerabilities. That is IAST. You may have heard the acronym IAST. It stands for Interactive Application Security Testing. And all it means is using instrumentation to detect vulnerabilities. And as you see, it's really pretty easy. We just made our own IAST using Jot, and you can make your own rules and enforce stuff. Jot comes with a whole bunch of different rules already kind of built in. And this is powerful. This is something that you can use today. There are commercial IAST products, of course, but Jot is completely free. Anybody can build their own IAST and find interesting vulnerabilities that would be hard to find in other ways. I strongly recommend that you use it during a pen test to give the pen testers feedback on what they're testing. IAST can reveal hidden parameters, headers that you didn't know about, a million different things that would be super useful to the pen tester. And there's rules for a lot of that already in Jot. The other thing I want you to think about is RASP. That stands for Runtime Application Self-Protection. And all that means is using instrumentation to detect attacks and prevent exploits. We just did that. We did that to identify expression language injection and block it from exploiting the application. So using RASP, we can prevent whole classes of vulnerabilities from being exploited. We can do it in a really surgical way, not like a WAF at the perimeter that's super noisy because it doesn't know what it's protecting. It kind of has to block anything that has, well, for expression language injection, anything that has a $sign and a brace in it, the WAF has to block it and say, hey, that's expression language injection, but it's probably not. 99% of those attacks never connect with their target. So using RASP, we can be really laser focused on what matters. So that's IAST and RASP. They often come together in the same agent, just like Jot, but they, in theory, I suppose they could be separate. But IAST is using it in development. You can put this, shift it way left, put it on developer machines and allow them to test their own code with IAST. You can put it in QA. It's super fast, so you can make it part of the pipeline without having to wait like 3 to 8 hours for a scan to complete and slow down your pipelines. IAST is really ideally suited for DevSecOps. And RASP is really simple. Development teams can adopt it, make it part of their application, and when it pushes into production, they're safe against numerous classes of attacks. This is why I think this is such a transformational technology. Let's talk about what we're, the big picture about what we're doing here. So, the legacy approach to AppSec is kind of what I call outside in. You're looking at a source code repo, or you're scanning from the outside, or you've got a firewall around the outside of an application. You never really know what's going on inside the running app. And that has a bunch of problems. When you're not inside there directly measuring the app or the API, you make a lot of mistakes. And if you have mistakes, you need experts. And if you have to have experts, you're going to slow things down because it's an instant bottleneck inside your software factory. You can run IAST in parallel across all of your applications. You can run RASP in parallel across all your applications and continuously monitor apps for vulnerabilities all at the same time. So imagine that. Imagine if you could be continuously testing every application all the time, finding vulnerabilities instantly. It's a much more powerful way. So that's kind of the advantage of this inside-out model. It directly measures applications using instrumentation, gives instant feedback and very accurate because it's directly measured. Like, it really can't report things that don't happen. And it's just there in the background, testing away in the background. It's passive. It doesn't require you to know much about application security. It'll just warn you when you kind of step over that line. So really a force multiplier for modern security, which is what's got me so interested in it. Ultimately, you can imagine this approach to application security really accelerating DevOps. Normally you'd have a pipeline that would have to go through scans at various steps and blocks and guards and gates. That really slows down the delivery of value to production, which is an anathema to development teams. They want to push code really fast. So with IAST and SCA and RASP, by the way, you can use IAST to do software composition analysis. You can analyze the libraries in an application from within the application itself. And again, you get this super accurate measurements. When you do that, then the feedback loops are really fast. Developers get instant feedback on their code. They can fix it. They can check in clean code. And we can automate the security checks during the pipeline and make the flow of code into production much faster. To me, that's the essence of DevSecOps, is getting that code flowing by using automation to really get security work happening. Okay, what we've seen is nothing short of spectacular. This is across tens of thousands of organizations. We report these in our bi-monthly reports, but you can see here some stats on mean time to remediate. This red line is for static analysis, and this is published by one of the major vendors in the SaaS space. They say, hey, we're going to get to a median amount of vulnerability closure in a little over 4 months. That's way too long. Get to 71% in a year. And actually, this is for smaller, simpler organizations. For bigger organizations, median is 315 days. Way too long to fix vulnerabilities. What we've seen with IAST is we get to median in 7 days, and 61% closed in 30 days, 90% by the end of the year. The area under this curve is a massive improvement in security. We feel really strongly that this is really, if you shifted security left, this is what the picture would look like, because most vulnerabilities are fixed in 7 days. Now, can we do better? Yeah. What we've seen is that with organizations that have been using IAST for over a year, they've tackled their security backlog. So generally, they don't have a vulnerability database full of vulnerabilities, tens of thousands of vulnerabilities. They've worked most of that off, and they're to the point where they're closing 75% in 8 days. I'm super proud of that. That's how AppSec should work. And I want you to look at IAST as an enabler to achieve these kinds of results and change the direction of your AppSec program. We'll throw it over for questions in just a second because I'm at the end of my time, but I wanted to point you to a couple articles that I think will really be useful to folks that are getting started in AppSec. The first one is called How to Vulnerability. And it describes how to talk about a security finding with development teams and executives, and how to be compelling. People always talk about the difficulty communicating with the business. This is the recipe for how to do this. These lessons were hard won. I spent 20 years doing this and started a consulting practice where I trained hundreds of consultants over the years in how to do this. And so, you know, I've made almost every mistake in the book. And so this is my tutorial on how to do it. The next article is what I call Making Security in a Software Factory. And if you're interested in kind of the big picture of how does security and software development really work together as opposed to being like separate siloed things, take a look at this. It's controversial. I make some broad criticisms of the way that security is typically done in sort of the traditional model. But I love your feedback on this because I do think this is a really important topic. With that, I will stop and throw it open to any questions if anybody has any.